In this video, I'll be explaining question 2 of homework 6. So we are given that f of xy is equal to b when x square plus y square is less than equal to 1 and it is 0 otherwise. So for the first part, we need to find b so that the given function is a valid joint PDF. So for this, we'll take the integral of f of xy dx dy over minus infinity to infinity for both x and y, and this integral should be equal to 1. Now if we see that x square plus y square is less than equal to 1, this is basically represents a circle. So circle of radius 1. So when we take the integral, we can basically say that f of x y is equal to b, and over integrating it for the circle it will be pi into 1 square, which is equal to 1, and therefore b will be equal to 1 by pi. Now for the second part, we need to find expected value of x. So we know that expected value can be given as x into f of xy, or integrating over minus infinity to infinity. F of xy is given as b, which we found out as 1 by pi from the last part. So this will be 1 by pi integral of x dx dy, where x and y range from minus infinity to infinity. Now we know that x square plus y square is less than equal to 1, so y square is less than equal to 1 minus x square. So y will range from minus under root of 1 minus x square to under root of 1 minus x square. So we will change the range of x and y. Basically this will be equal to x dy, where y range from minus under root of 1 minus x square to under root of 1 minus x square. And yeah, so if we see just this integral, since it is an odd function, this will be equal to 0. So expected value of x is equal to 0. Now we need to find expected value of x given small y. So this can be written as x f of x given y. We'll take the integral over it, and f of x given y can be written as f of x y upon f of y. Now first let's find f of y. So f of y is basically integral of b dy, where pi range from minus under root of 1 minus x square to under root of 1 minus x square. So this will be equal to 2b under root of 1 minus x square. Now to find expected value of x given y, we'll just substitute the f of y that we calculated and take the integral. Here to find the integral, we are substituting 1 minus x square to t square. So minus 2x dx will be equal to 2t dt, and when we take the integral, we'll find that it is equal to 0. Now we need to find expected value of x given capital Y. So we can just use the previous part to find this. We can just substitute small y equals to capital Y, and the rest will follow in a similar manner. So this will also be equal to 0. Now to find expected value of y, so since we know that the given function is symmetric about x and y, so x and y will lie in the similar range, and therefore this integral will be equal to 0. And similarly, from the previous parts we can conclude that expected value of y given small x, expected value of y given capital X, these both are 0 as well. Now coming to expected value of xy, so that will be equal to xy, f of xy, dx dy, and we take integral over minus infinity to infinity for both x and y, and f of xy is b. So first let's integrate over x, so by dy, let's integrate over y, so by dy, where y ranges from minus under root of 1 minus x square to under root of 1 minus x square, and we can clearly see that this is an odd function, so it will the integral will be equal to 0. Now for the last part, we need to prove or disprove that x and y are uncorrelated. So clearly from the above parts we know that all the expected values, which is expected value of xy, expected value of x, and expected value of y, all of them are 0. So expected value of xy is equal to expected value of x times expected value of y, and from this we can clearly say that x and y are uncorrelated.